everyone, I'm Li Hui. In this course, I'll introduce some typical types of sites in a WDM system and their networking and internal structures. We'll use the high-speed railway to help illustrate this concept. This is the high-speed railway between Zhengzhou and Wuhan. These stations are the origin and destination stations, and all train passengers will either get on or get off at these stations. This railway also passes through intermediate stations such as Xuchang and Xiaogan, where passengers can stay on the train for their stop. In the WDM system, we refer to sites like Zhengzhou and Wuhan as terminal sites or optical terminal multiplexer sites. These sites allow adding and dropping of all services. Intermediate stations like Xuchang are called WDM sites. They allow some services to be added or dropped and other services to pass through. As WDM signals are transmitted along optical fibers, the signals will weaken and may not be detected by the receive end. To help fix this problem, sites that amplify optical signals are configured, which are called optical line amplifier sites. In addition, in order to solve the problem of OSNR deterioration, certain signals need signal regeneration. The signal regeneration site is called a regeneration site. Next, let's talk about the compositions of each site type. OTM sites allow only one direction for light, meaning that all optical signals terminate here. As shown in the figure, OTMs are composed of 5 parts: optical transponder units, optical multiplexer or demultiplexer units, optical amplifier units, optical supervisory units, and fiber interface units. Let's look at these functions of each part. The OTU converts gray signals into colored signals. The MUX and DMUX multiplex and demultiplex multiple wavelengths. The OAU amplifies the optical power of signals in all wavelengths. The optical supervisory unit uses a unique wavelength to carry optical supervisory signals to connect with the network management system. The FIU merges all service signals and supervisory signals and sends them to the optical path for transmission. In the transmit direction, the OTM site converts service signals from SDH or datacom devices into standard WDM wavelengths. Then that MUX unit multiplexes the signals into one beam of light. After being amplified and merged with supervisory signals, the FIU connects to the optical fiber and transmits them. In the receive direction, the FIU separates supervisory signals from service signals in the optical cable. After the service signals are amplified, the DMUX unit demultiplexes the single optical signal into multiple colored optical signals. Finally, the OTU converts them into standard signals that can be received by the service end devices. The OADM site is also composed of OTU, MUX, DMUX, OAU, optical supervisory, and FIU units. An OADM site is equivalent to 2 or more OTM sites and can implement service adding or dropping and pass through in multiple optical directions. We can further categorize OADM as a fixed optical add or drop multiplexer, or a reconfigurable optical add or drop multiplexer, RODM. FODM allows only the adding or dropping of fixed wavelengths, whereas RODM can flexibly and dynamically adjust the adding or dropping of wavelengths. The OLA site is composed of FIU, OAU, and optical supervisory units. The FIU first demultiplexes the optical supervisory channel and service channels, and then the OAU amplifies the service channels. Finally, the supervisory channel and the amplified service channels are multiplexed and transmitted. The last site type is the REG site. An REG site does not add or drop services. It only enhances the OSNR to extend the transmission distance. REG is composed of 5 parts: OTU, MUX and DMUX, OAU, optical supervisory, and FIU units. At an REG site, signals that need regeneration are sent to the OTU for retiming, reshaping, and regeneration, also referred to as the 3R function, and then continue transmission. As you can see from the description above, the site distribution of the WDM system is complicated. So a question is raised: what kinds of networks can these sites form? The WDM system has four main networking types: point-to-point, chain, ring, and mesh. Let's look at the point-to-point networking first, which is the most basic mode of networking. All services are added and dropped at two OTM sites. However, if the two sites are too far apart, then OLA sites are required to handle the optical power losses caused by line attenuation. Generally, an OLA site is required every 80 kilometers when using high-quality optical fibers. If the OSNR is severely degraded during transmission, REG sites are required to regenerate signals. In practice, networks with only two sites are uncommon. Usually there are multiple sites that allow the adding and dropping of services on optical fiber links, which combine to form a chain network. Factors which need to be considered in a chain network are the same as those of a point-to-point network. We need to add OLA sites and REG sites according to signal amplifying and regeneration requirements. As the service develops, if the OLA sites and REG sites need to perform service adding and dropping, they can be upgraded to WDM sites. However, point-to-point and chain networks have low reliability due to the lack of a protection channel. If the optical fiber breaks, services will be interrupted. Therefore, these two networks are only used when there are few optical fibers. The third type of networking is the ring network. It is a widely used network type which can be further adapted into a mesh network. As shown in the diagram, there are two routes between any 2 points in a ring network, ensuring that services are protected by a backup route. Normally, the working route is the link with the optimal performance in optical power and latency. If the working route fails, the ring network is able to switch to the backup route within 50 milliseconds, meaning services will not be interrupted. Having this type of protection mechanism is a basic requirement for telecommunication services. The last type of network is the mesh network, which is a relatively complicated network. It integrates point-to-point, chain, and ring networks into one network. The mesh network can provide multiple routes for services, allowing for more flexible backup route choices. However, the design of a mesh network needs to consider the physical parameters of every service route, such as the optical power and OSNR. Usually, after the service demands are confirmed, assistive tools are used to design the site types, network topology, and channel diagram. In this course, we have learned about the different types of sites in the WDM system and their compositions, as well as the network topology of the WDM network. Is everything clear so far?